Hello, everybody. Welcome to another episode of the Extreme Performance Series. I'm Todd Muirhead, and today I have with me Mark, longtime friend of the show. How you doing, Mark?
Very good, Todd. Thanks for having me back.
So, Mark, what are we going to talk about today?
Well, one of the interesting topics that still comes up is, vSockets, vCores, vTopology. So I thought let's take that apart again one more time for folks because it's totally relevant to everybody still. And there still seems to be kind of a lot of confusion around this space. And so I wanted to take a few moments to walk through it with you and tidy this up for folks. So who should really care about this? And everybody should, because this topology, the way we lay out sockets and cores and NUMA, really affects things like performance. It affects OS licensing. It affects applications like SQL on top of these systems. And this is something we spoke about in a blog article back from 2017 that's actually still regularly referenced. And this is one of the charts where I used to walk through some examples with folks. And so maybe we'll take a moment and just walk through an example and see what that looks like. So in this chart here, this kind of shows an older platform, shows you how long we've been speaking about this. 2 physical sockets and 10 cores per socket. So if I want to create a VM with 10 vCPUs, by default, we'll create that as 10 sockets, 10 virtual sockets in the vSphere platform. But really, kind of the optimal topology we want to put into place here is that it should be 1 virtual socket with 10 cores per socket, because that's like physical. And that, again, will affect things like soft NUMA for SQL as a feature, depending on the topology it sees. So this article we've been talking about has some great information, has some of the history around it, and has really where this conversation started. In vSphere 8, we introduced a feature called vTopology. So this is actually the automation of ensuring that the VMs get this proper topology in place, because by default, like I said, we kind of spread things pretty wide with vSockets. So now there's a whole system of logic behind this. When we boot up a VM, it looks at the physical platform, it looks at how many vCPUs you asked for, and it will configure the right vSockets, vCores, and vNUMA for that VM. And there's a performance study here, and there's a link to it that goes into a lot more great detail that kind of shows it off. But when we zoom in to the setting around this is kind of what it looks like, right? You still choose a vCPU count, 12 in this example, and the topology is left at assigned to power on. So the first time this VM boots, like I said, we'll go through the logic of the blog article and we'll create that right topology. And again, it's optimal for how the guest operating systems will consume those resources and then how the applications will layer on top of it. So this is very powerful to have in the vSphere 8 and obviously the VCF 9 platforms. And this is just an example of the tile here that shows after a VM booted, we can see that in this case, it created 1 socket by 12 cores per socket. And that's the default behavior we want. Previously to the vTopology feature, I would suggest we kind of created things suboptimally. We used a default where everything was a socket unless we manually intervened and followed something like that blog article's logic to set some of this up. Now, the challenge with that is unfortunately, everything that's been created now likely has a topology that I'll consider suboptimal. It's all these sockets everywhere. And every time we take a VM and we move it through versions of our platform from 8 to 9, that configuration was written. And we're not going to change that configuration without you intervening or without you saying to do that, obviously, to reduce risk. The problem is now these environments, even though we have vTopology, they're still configured suboptimally. And so there's potentially an effort to go back and look at some of those again and reconfigure some of those.
So, Mark, that's exactly why we're still talking about this today, even though it was fixed in 8.0, and now we're in 9, VCF 9. Is that as we, like you said, we're not going to change the existing topology for VMs that were created on previous versions, and so it just gets carried forward, right, as the default. And new VMs that were created with this, and this would have been the default. So it's
That's
just
exactly it.
so that's why it's still persisting in the environment in in these VMs that are being migrated across the new versions as they come out.
And the other piece too is depending on how customers provision these VMs? Are we using our the VMware automation tools? Are we using some other provisioning system? Do we have a number of scripts? Depending on that provisioning model, you may not even be taking advantage of vTopology necessarily, because you might be actually injecting a configuration against it here. So while the logic's in place to do this, again, depending on the steps you have put in place, you still might not be able to take advantage of it. So I do think there's a lot of confusion out there still, and there's definitely a lot of VMs configured using the old method. And so I guess the question I'm often asked is, what should we do about this? Should we go back and look at VMs in the environment, and should we reconfigure things? So there was a tool that a peer of mine created in the past. It was called Virtual Machine Compute Optimizer. And it's really a fancy PowerShell script that goes and looks at your virtual machines across the environment through vCenter. And it looks at how they are configured, and it looks at how they should be configured using that right topology, and we'll kind of set a flag to say whether it's optimal or not. And so this is a great method to go back through an existing environment, regardless of the version of the environment, to take a look at how all these VMs are configured, or to understand the scale at which these configurations exist. And then there's likely some percentage of that environment that would benefit from a reconfiguration. Great examples would be database servers, right? That the presentation of 8 sockets, or one socket with 8 cores, will change the performance profile of a database engine. So for larger VMs, monster VMs, database VMs, you'll want to go back and take a look at that topology, as well as latency sensitive VMs. So even smaller VMs with 2 or 4 vCPUs could benefit from that topology, because of how latency sensitive workloads work, and the way the threading model happens inside the VM. So again, great tool here, still accessible through the Broadcom community Flings page. And just a couple of data points to show. Again, lots of people say, well, does it really make that big a difference? And for some smaller workloads, it may not, but generally it's never going to decrease or hurt performance. It will always improve performance, or worst case, keep it the same. But what we've seen running through a bunch of performance tests here is that throughput actually increases and latency actually improves. And if we look at that in scale in an environment here with a number of VMs, optimized, doing things more efficiently, that's better for the application experience, for, system KPIs in general. This was an example with Cassandra. And then this was another example using DVD store, again, looking at topology, increasing overall throughput.
Yeah, these are great examples of how you see these performance improvements pretty much across the board. Or like you said, worst case, it'll be a neutral kind of change.
That's exactly it. So there's absolutely no risk in using these features, pivoting, some of these VMs to a proper configuration. I often recommend to the customers I work with, if you get a support call, somebody's complaining about performance on a VM, one of the first steps you can do operationally is look at this topology, optimize this topology, and then let's look at if there still exists a performance problem and kind of take it apart. But you'd be surprised at how often this will actually improve that performance.
So, Mark, any other key points you want to make about this?
No, I think the most important point here is that there's been so much confusion in the past. We've certainly changed the way sockets and virtual sockets have behaved. We've really tried to help our customers out with, automatic functionality with the vTopology feature. But I think it still really pays to do your homework in an operational state and go back and take a look at some of this environment, just because many workloads were created years ago and continue to exist today, and will likely continue to exist for years. And so, as an operational kind of, day 1, day 2 scenario, you want to take a look at those. Like I said, build in some processes to take a look at these as you go along. But certainly, like I did a shout out before for like database and latency sensitive, there's a percentage of environments that could benefit from that today, right away.
Yeah, by and large, I feel like the vTopology is like the easy button. It's just kind of recognizing that in all cases, it may not have been pressed. Going back and understanding, like you said, what's going on. This is potentially the solution.
Well, thank you, Todd, for allowing me to share vTopology with everybody again today. And certainly check out the resources that are available beneath the video here.
Yeah, thanks, Mark. And thanks everybody for joining us for another episode of the Extreme Performance Series. And we look forward to seeing you on another episode soon.